All right, so here we are, part 3, last step of hopefully understanding the beginnings of vectors in space. All right, so one of the things is, okay, so we've talked so far about adding some vectors. We talked a little bit about subtracting some vectors. But what about multiplying vectors by a scalar? What is a scalar? Okay, you know the word scalar best as constant. Okay, it's a number. Okay, any number, how did I get that in a number? Okay, any number. And here's the kind of key point. If the number that you're going to multiply, if k, your number you're going to multiply, is bigger than 0, then it moves in the same direction. If k is less than 0, or if the number you're going to multiply is negative, k moves in the opposite direction. So let's see how this works in not real world, but in our math world with just vectors. So first one here says draw a vector diagram of a minus 3b. So what does this mean? This means that first thing I need to do is I'm going to take a, and I'm going to do, so here's a, and I'm going to draw a right here. It's going to be the exact same thing, parallel, same everything. Here's a. So I draw a, it looks about the same, looks about in the same direction. And I want to do a minus 3b. Well, I don't know what minus 3b is. They give me b. So we're going to work this out. To do a minus a 3b, first thing you do is you make a negative b. We already talked about that. Looks exactly the same except the tail and the head switch positions, and here is now negative b. And how many negative b's do I want? I want 3 of them. So I do, here's a negative b, a little bit longer. Here's another negative b. Here's another negative b. This whole distance right here, that's a negative 3b. I want to go a minus the 3b, so I subtract out the 3b, and I go this way with this minus 3b. There's my negative 3b. And then when I put my resultant vector in, when I put that, this right here gets joined up. Let's try that again. This right here gets joined together, close enough for both. And this right here that's my a minus 3b right there. And there's my vector diagram of a minus a 3b. Okay. So next one's not nearly as complicated, and I'm going to want you to do it on your own. So here we go. Next one. There it is. It's asking for n plus 2m. I'm going to go ahead and pause the video. You guys pause the video. Pause the video. Pause the video. Pause the video. Bam! There it is. Okay. Hopefully you got the same thing. Notice here's the 2m. I drew the n the same way. The 2m goes there. My resultant vector is the blue. And that's my vector diagram. So now comes the hard part. We do the applications. We got to do applications of this. So here we go. This is the bulk of where my conversation is going to be. This is just like what we did before. So here we go. It says an airplane is flying with an airspeed of 475 miles per hour on a heading of 070 degrees. So again, I'm going to start drawing this out. 070 degrees, that means I go north. I draw out here 70 degrees. There's my vector, and it's 475 miles an hour. That one you should have by now. Okay, I'm not going to argue with you on this. This one you should have. So let's talk about the next one. This next one is a little bit harder. It says, if an 80 mile per hour wind is blowing from a true heading of 120 degrees. What's a true heading, you ask? It's the same as what we talked about earlier. A true heading is starting at the north line and going 120 degrees. So there's my east line right here at 90 degrees. I'm going on another 30 degrees more to get to 120. And this is where wind gets tricky. It says blowing from a true heading. So there's my 120 degrees, but it's blowing from there. So here is my 80 mile per hour wind. And there it is at 120 degrees. Okay, and it's going to ask me, determine the velocity and direction of the plane relative to the ground. Determine the velocity and direction of the plane relative to the ground. Okay. So, what does that mean? It means my resultant vector. So it means if I take this wind right here and I put it up here, there's my 80. My new resultant vector right here, what is that going to be? What is that direction? So it's asking, what is this? That's my direction. And what is the magnitude? I'm going to call that my resultant, my R. So it's asking for what is the magnitude of R and what is my direction? What is my bearing? So again, we're going to break it up just like we did before. I'm going to call the airplane vector A. I'm going to call the wind vector W. And we need to break it into its component parts. Let's deal with the airplane first. It is by far the easiest of them. And I'm going to save this spot for our answers. So, my airplane. So, we need to break up A sub X, A sub Y. The 475, cosine of I don't know yet. And again, 475 of sine of I don't know yet. Now, what's my degree measure I'm going to use here? My degree measure, well, it's not the 70 degrees here to get to the A, it's what's left over. Again, remember, my degree measures for finding the component parts go from the x-axis over, up to the line. So for the x-axis up to the line, that's 20 degrees. That's what's left over. So it'll be 20 degrees, 20 degrees. I go into my handy-dandy calculator. Oh, I don't need to worry about that, but there's my broken components right there. That's easy. Boom. The W ones get a little tricky. So let's take a look at those. When I redraw this out, my wind was here, like this, where this was 120 degrees. But I don't want the head touching my intersection. I want the tail touching here. So that means I'm going to move my wind. I'm going to take this, I'm going to move it right here. Move it like this. And to make a straight line. So now when I do that, this is still 80 degrees. Right there. I need to find out what this degree measure is. Well, I know that this little bit was 30, right? This little bit was 90. That's a straight line, forms 180 degrees. 30, 90, oh, what's left over? 60. Why did I need to find that? Again, to break it into my component parts for WX and WY, the easy part is knowing this is 80 cosine. I know this is 80 sine. But what's the degree measure? From the x-axis to where I need to go. From the x-axis to the vector. So x-axis, you get 90 degrees plus another 60. That's 150 degrees. 150 degrees. All right. Again, I find this out. I go and find out what R is. Okay. I find out RX. RX, remember, it's my resultant. So it's AX plus WX. Tap, tap, tap into a happy dabbity calculator. And it tells me that it's 377.07. And then RY is equal to AY. plus WY, which is then tap, tap, tap away, 202.459. Great. But I want magnitude of R. How do I find magnitude of R? I find magnitude of R by, sorry about the extra noise. I find magnitude of R by doing the square root of, right, Rx squared plus Ry squared. Again, I go tap, 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 tap in the handy dandy calculator, and my magnitude, which is now my speed, is 427.986 miles per hour. So what does that mean? Does it make sense that I'm going slower? If I'm going this way on an airplane and I have a wind pushing me this way, am I going to go slower? Yeah, I'm going to go slower. About 50 miles per hour slower. It's quite a bit. Now, what's my degree measure? Again, remember my degree measure? To find my degree, I got to do inverse tangent of Ry over Rx. Again, I go tap, tap, tap away, and I find out that that's 28.232 degrees. But is that what I want? No. Why? Because that 28.28 degrees is right here. That's from here, from the x-axis to the vector. X-axis to the vector. That's not what I want. What do I want? I want the direction relative to the ground business. That's this angle up here. So I subtract 90 degrees from that. When I do that, I go ahead and I'm going to get tap, 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 061.79 degrees. Ta-da! There's my answer. A lot of explaining, a lot of figuring out. This is not easy. I want you to watch this problem again, at least once more. I prefer twice more. Please. Okay? The next one's not nearly as hard. This is the one where you can take a break, take a breather right now. Just stretch yourself out. That was intense. All right? Now we get to breathe a little bit. Okay, so here we go. We got this girl. She's shoveling. I guess it's Will, so it's a guy. Sorry, Will. All right, so Will pushes a shovel into the ground with a force of 630 newtons at an angle of 70 degrees with the ground. Draw a diagram that shows the resolution of the vector force that Will exerts into its rectangular parts. This is where the book and I disagree. The book wants you to draw just a simple vector diagram like this, but to me, the force is not coming out. He's telling you to put the force into the ground. So again, I'm going to say if I'm going to draw this on a little coordinate little thing here, here's my vector. It's being pushed into the ground, right? Pushing it into the ground. So in order for me to find out its component parts or draw its component parts, I need to slide it to where the tail is at the origin. Here is my 630 degrees. Here is my vector going this way, my horizontal, and I'm going to call this one Vx, and they want this one here Vy. So that's taking it to its rectangular parts. That's part A. Okay. Part B, so there's part A. Part B I might as well just do right here as well. Okay. Part A tells me that this is 70 degrees I'm pushing into the ground. Again, I want from the x-axis all the way over to the vector. X-axis all the way over to the vector. So how do I do that? X-axis all the way to the vector. How many degrees is that? Well, here I am at 70. Hey, so how much is this? This is that whole vertical angles again. So this is also 70. So 70 and 70. So 70 all the way over, that's 180 plus another 70, 250 degrees. So my Vx component is going to be 630 newtons cosine of 250 degrees. and Vy is equal to 630 sine of 250 degrees. And that breaks it into my components. And that's it. I'm done. You go tap, tap away if you want to find the actual answers. You can. You're going to get two negative answers. Why? Because you have negative components going to the left and going down. And then, all right, I can leave you to tapping around. That's it. Hope you guys are doing well with this. Again, this is a difficult one. Please watch this one a couple of times. See you guys later. Bye.